Okay, I just want to go over using a micrometer and vernier scales. Obviously, everybody's done this in their practical lessons when they've done investigations, but it's just a quick reminder of how to use a micrometer and how to use a vernier scale. So the first one here, I'll just remind you of what a micrometer looks like and just go over how to measure it. So here we've got a micrometer. So we can see here, this is going up in millimeters. So we can see here we've got 0, then 1 millimeter. Apologies, we've got 1 millimeter, 2 millimeters, and so on. Now we can see here these lines represent half millimeters. Now this one's very difficult to see, but we can see that we've got 1, 2, and a half. So now we've got to decide on our next, what is this next decimal place? Now here there's a nice applet which shows us how to do this. So when we slide our scale, we can see here that we've got, as we slide it, we can change the reading we've got. So what we're looking at is we've got 1, 2, 3, 4, 5, 6, and then the next number here corresponds to the number of decimal places. So we've got 6.3, I think that's a 3 there, 6.33 millimeters. Now if, however, we go to there, now this is more complicated because we've got 5.5 and then we've got 2.6. So we've got 5.5 plus 0.26, that would be 5.76. So a nice larger example of that is here. So here we've got, let's show the measurements so it's nice and easy for us. So if we look, as we take our, we'll move our ratchet in and out. So let's have a nice look and make it a nice easy one. So it says 1, 2, 3, 4. We don't go to the next half millimeter, so it's just 4 point something. So now we look at this scale, and it's got 30 to 33. Now the line here lines up with 1, 2, 3. So that would be 1, 2, 3, 4.33 millimeters. When it's more complicated slightly, what happens is, it's when we go over this half point. So here we've got 1, 2, 3 millimeters plus a half. So it's 3.5 plus, here we've got 0.38. So it's 3.5 plus 0.38, which gives us 3.88 millimeters. Now, micrometers are not difficult to read at all. It's just really important to make sure that at the beginning there's no zero error, and that's typically when we use a micrometer, say we're measuring the diameter of a wire, say, so a resistivity experiment, we would measure it several times along and we would take an average, a mean, so that we could identify any anomalies and remove them. Okay, and using a vernier scale is the other one. Using a vernier scale is exactly the same in that it's very, very straightforward. So that's what a vernier scale looks like, or that's an example of a vernier scale. And this here is how we read it. So here we've got a vernier scale. Now there was a question on this in the exam some time ago. And some confusion arose because the students, what they were doing is, they were looking between the gap here, and this was on the examiner's report in one of the papers that's gone previously. They were looking at this line here, and they were seeing where this lined up with this. Now, when it's closed, when the jaws are closed, you see that they don't close on the zero line, they close prior to that, they close before that. So this little space here is exactly the same size as the space there. So when we're looking at this, we're not looking at this point here, we're looking at these values here. Okay, we're not looking at this point here. So we're looking at where this point here, the first one, is lining up. So let's have a look. When we look back, it says we've got across here, we're in centimeters. So it's saying 1 millimeter, 2 millimeters, 3 millimeters, 4 millimeters, 5 millimeters. Now the answer lies, this line here lines between 5 and 6. But we have to decide then, well, which point is it? So in order to find that out, we look at the top scale. So we count along and see, where is it where the lines suddenly line up? It's not at the end here, it's not here, it's not there. So if we look, as we go along, it seems that this point here is the point where they line up. So if I just show you here, 1, 2, 3, 4, 5, 6, 7. On the 7th line, that lines up perfectly. So this shows us that the reading on the vernier scale would be 1, 2, 3, 4, 5 millimeters, and it would be 5 point, and it's the 7th one it lines up on, so it's 5.7 millimeters, or in this case we're in centimeters, so it would be 0.57 centimeters. I'll just do another one randomly just to show you the point again. So here we've got 1 centimeter, and then it goes 1, 2, 3, 4. The answer lies between 4 and 5, so it's between 1.4 and 1.5 centimeters. If we look, where do they line up? And it seems to line up 1, 2, 3, 4, 5, 6. It seems to line up on the 6th point, so it would be 1.46 centimeters. That's all you need to know about using these pieces of equipment. A vernier scale, there are 2 different types of vernier scale. Obviously, there's this one here, or typically when we're doing Young's modulus, we use a sliding vernier scale in a different arrangement. However, the reading is exactly the same. We're just going from 0 to our first point. Then we're seeing our next decimal point is where it lines up on this small scale here.